This is what some people call the world's largest mirror.
You see essentially an infinite layer of water, and the sky is reflecting.
The still lake creates a perfect copy of clouds, mountains, and people. But is it really a perfect mirror? And why doesn't the wind ruin the effect? This group of scientists decided to find out, using a combination of high-tech and low-tech science. This is the Salar de Uyuni in Bolivia. It's the world's largest salt flat. In the wet season, it's covered by a thin layer of water and attracts tourists who want to see the incredible mirror effect. Stefano Vignadelli and his team set out to determine just how flat and smooth the surface of this water really was, and they used floating beads.
We have 2 cameras showing the surface, and then we had beds moving.
Then they analysed the footage to calculate the height of the beads at each moment.
So using the video, we could essentially determine the 3-dimensional, so if the surface is going up or down.
The results matched what their eyes were telling them. The surface of the lake was incredibly flat, hence the crystal clear reflections. As they took their measurements, a European Space Agency satellite passed overhead and bounced radio waves off the surface of the lake. When the water is flat, the satellite receives the maximum amount of backscatter, the reflection of the radio waves coming straight back up.
If the Salar is a big mirror, we should see all the time, in all places, the maximum backscatter. But we don't see that.
What the satellite data actually showed was that although some parts of the lake were acting as a perfect mirror for some of the time, it wasn't uniform. There were always at least some parts of the water that weren't flat.
So that's why what the people normally said in the book, in the papers, that Salar is the bigger mirror in the world is not really correct.
So the Salar de Uyuni is not technically one big perfect mirror. But as can be seen with the naked eye, the flat water does act as a mirror over large areas, with satellite and on-the-ground measurements confirming the smoothness of the surface. But how the water stays so flat is a puzzle.
It's a big area, no? 10,000 square kilometers. And so wind is there. But the water is not creating waves. So that was the first intriguing question.
It could be that the water is too shallow for waves to form. It's generally only about 2 centimetres deep. Or it could be something to do with the high salinity or the salt flakes floating on the water's surface. Figuring out exactly how the effect works is the next part of Stefano and the team's work. But there are other mysteries here.
Another surprise was that the water was moving.
Despite the lack of waves, the water was moving. The beads floating along revealed currents, not flowing downhill, but being pushed by the wind.
The water current changed direction in response to the wind direction change. And this is all never documented.
So the wind here does impact the lake, but instead of waves and ripples, it makes currents. For Stefano, it shows how much is left to discover about this wondrous place.
I think that is the unique location, the landscape around that made a wonder. We say the 8th wonder of the world.